This is Flutter. Yeah, so I'm going to talk about, instead of talking about Android stuff, we're going to talk a little about Flutter, which is Android, but also other things. So we're continuing in the vein of exploring a little outside of Android proper. So we will see no Java, no Kotlin. We will instead see Dart, which, anyway. Cool. So, hi. I'm Anna. I'm a software developer. I worked for a bunch of different things outside of mobile stuff. I worked on the GitHub desktop app at GitHub. And then I worked at the Slack desktop app. And so those are two very different apps, but they kind of shared this theme of what I kind of work on in general, which is cross-platform applications. So applications that you write on one platform and you share things between them, and you get it on all three platforms. So these were desktop applications. First, I wrote code with Xamarin and C#, and then Slack Desktop is written with Electron, so it uses web technologies. And so now I'm really interested in Flutter. And so let's talk about Flutter. So I really wanted to learn Flutter, so I wrote I wanted to write a real production application, like kind of not a toy, something that has the login, has like a full application, and kind of tell you about it and see what happens and whether it works or not. Since Flutter is really new, who here has heard of Flutter and kind of knows what it is? Who here has no idea what I'm talking about and you're like staring at me like, what is she saying? Okay, so we'll see a little bit about what Flutter is, but the idea is that you write your application and it runs on both iOS and Android. So it's not like it's not a web application. It's using native technologies, but we'll see why it's a little different in a little bit. So I wanted to talk about a few different things that I learned while putting together a real application. And so the motivation is in April, I got surgery on my voice to sound like this and not like this. So as part of that, for 3 weeks, I wasn't allowed to speak at all. No talking, no whispering, no communication of any kind. Of course, I'm like, how am I going to get around? My solution was to write an app, because when you've got a hammer, then the entire world looks like a thumb. So I wrote an app called Sirene, and it's a text-to-speech app for day-to-day use. Now, if you go in the Play Store, you'll find a lot of text-to-speech apps, right? There, tons of them. But they're really not designed to be used for like day-to-day. They're really, a lot of them are like tech demos, or like really like they lack a lot of usability, especially, and this is really important if you're using this, relying on this to communicate with other people, right? Because these small usability problems really add up when you use it, 50 times a day, or just they didn't have really great design. So I want to design an app that not only does kind of the basics of like being able to type a thing and hit a button and hear it, but to be able to keep up in a conversation. So Sirene is a cross-platform Flutter app. It uses a lot of like interesting kind of Google technologies. It uses Cloud Firestore to store what you've saved online. It uses auth, you log in with Google to kind of associate it with your account and your saved phrases and stuff like this. Uses Sentry for error reporting, Firebase Analytics. I wanted to kind of explore and play around with all the new kind of cool technologies to build real apps. So as you can see, when you start to type something, you start to see your saved phrases below it, right? So these two, yeah and bye, are saved phrases. The other part of this app is kind of like the save phrases page, where you can see a bunch of like canned phrases that are really common in conversation. And so actually, the way that I generated this list was I went online, there's this web page that has the closed captioning for every episode of Friends. And a bunch of other TV shows. But Friends I thought was really good because it's like regular people talking normally. So I took it and statistically analyzed it and took the top 50 phrases or whatever mold it a little bit. And I also categorize by whether they're apply or not. So often you say something, and then somebody asks kind of a follow-up question. You say maybe yes or no, or what, or thank you, or I didn't know. So as soon as you say something, it'll switch into reply mode and immediately have the list sorted by usage, how often you use these things. And so all that stuff I had to store in the cloud because I want to keep counts of all these things to be able to sort them properly. By like usage and recency, like how often you used it recently. And so I did some other cool stuff too. It uses when you type in a custom phrase, like on this page, we use MLKit, which is a brand new library from Firebase, to detect the language that you wrote that phrase in. And that's important because I'll show you why. So in my house, we're a multi-language household. I talk with my kids in German and I talk with other people in English. So we say both all the time. So here's why.
Hallo, ich kann Deutsch sprechen.
Ah, that was loud. Wow. All right, let me see if I can fix that. Let's try this again. So you heard that? It said it correctly in proper German, super distorted. This is if you don't use MLKit.
Hallo, ich kann Deutsch sprechen.
I tried to fix the levels and it didn't work. All right, but you can hear that it's somebody speaking German in an awful American accent. Yeah. So this is what else the app does. When you actually play a phrase, it shows it whether your phone is in portrait or landscape. It shows it in landscape. It shows it in big text, so you can hold it in front of you. So when you say something, if they didn't hear you, because phones really aren't that loud. Like if you're in a crowded room, you can turn your phone all the way up and you're not going to be able to, somebody's not going to hear you, right? You can, especially if you have a pop socket that's really useful, you turn it on the side and you can show it to somebody. So those are really useful when I was like ordering coffee, something like this. So this is actually in GitHub. It's an open source project. You can build it and run it. You have to create a Firebase project, but it's pretty straightforward. You just follow the instructions. I will say that this is not what's the word I'm looking for? A beacon of software design. So I think the structure is really great. It's really a place that I use to explore how to build Flutter applications, and we'll kind of go into why in a minute. And so because I really had a deadline, because I had to finish it before I couldn't talk, so it's a little rough. But I think there's a lot of interesting pieces, and I'm glad that it's open source still, so you can check it out. It runs on iOS and Android. I'm working on getting the iOS App Store, but I'm running into weird signing issues. Of course, if you've ever done iOS, then you know what fun that is. Cool. So a lot of people ask this question when they start to build their first real Flutter application. How do I choose what design pattern to use? How do I structure my application? And they ask this question because there are a lot of answers. So there's this library called Mobex. There's this library called Provider, which is actually built into Flutter. There's this pattern called BLOC. The funny thing is I asked the Flutter, there's kind of a professional Flutter group, like a Slack. I asked them, what does BLOC mean? Because it had all these very vague definitions. I was like, okay, well, it has to use streams, it uses RX streams. And they're like, no, you don't have to use streams. I'm like, okay, well, it uses view models. Okay, you don't have to use view models. I was like, well, what does BLOC actually mean? And they're like, it just means you use another class. Nobody knew. Nobody could tell me. And so basically everyone feels like this. Nobody knows. And in my opinion, that's why Flutter is cool. So this is what really excites me about Flutter, is that it is so wildly different from everything that's come before it in terms of native UI paradigms. A lot of native UI toolkits are really kind of didn't evolve much past the 90s almost, Windows Form style. And they kind of all have the same thing. They have a tree of widgets and they're all very mutable and you poke around with them and set properties and stuff like that. And Flutter was kind of the first they really retook it and said, how do we design a UI toolkit in 2019 and not 1994? So for example, you can run unit tests on widgets, like on controls. You can't do that in Android, you can't do that in Windows, you can't do that in iOS without these really fragile, easily broken kind of frameworks. In Flutter, it's built in. Everything is set for testability. And so that really changes the game for a lot of like we built view models because UI controls weren't testable. It's like, well, what if they were? Then it kind of like everything you know about building applications is different. And I'm personally someone who really likes thinking about the structure of applications and how to write applications elegantly. And I think this is really great. So, of course, that doesn't help you guys at all. I didn't answer the question. But what's right for you always depends on your team. And that's really important. You need to matching kind of your structure, your complications, or the way that you design things, whether it's super functional, whether it's very imperative, depends on your team. It depends on how they kind of view writing applications. So I didn't answer the question, but I'll help you to answer it for yourself. So what makes a good design pattern? That's something when we're kind of coming up with our own, because in Flutter we kind of have to. How do we make our own design patterns? When we design things a certain way, the idea is that we pay something up front. We have this cost. We're doing something in a way that's not the most immediate way. We're paying this cost in order to get some benefit, right? We're structuring it. If we're going to put up some upfront structure, and then it's going to make something easier, or better, or faster. And so one thing that's really important, I think, to point out is that kind of structure for structure's sake isn't a benefit, right? Having layers and layers and layers of abstraction doesn't make things better. It makes everything more complicated. Every design pattern has a cost, and if you're not getting a benefit out of it, then it's not great. So these are my kind of Zen moments. And this kind of applies, it doesn't just apply to Flutter, it applies to Android, it applies to iOS, it applies to anything you're building really. I know it's hard to believe, but code is a way for humans to describe things to each other. It's true. So a computer, also reads code and does something with it, but really the most important value of code is that it tells other people how something works in a very detailed way. And in my opinion, you know that a pattern is great when you can hire somebody new who's off the street, who knows a framework but doesn't know your code, and can read it and read a piece of code and say yeah, I know what that does. The mental model that I build when I read this code is the same as what it actually does. So that's a cool thing to have in a design pattern. So design patterns should make most code faster to write. So this is really important, and I see people make this mistake a lot. I saw this talk in this comment in a Google talk, and it really stuck with me. They were talking about Google really likes to tell people about software but not release it. They'll be check out this cool thing, we built it, it's really great, and then you're where is it? You're oh, you can't have it. So it's one of those talks. And so he says, push complexity down the stack. And I thought that was really powerful. It means that most people should not have to think about complex things. The goal is that you want to have one person think about something complicated and push it way down in the stack. And then everyone else writes simple code that is straightforward. And so only one person has to write complicated code. And instead, the alternative is if you build a system where everyone has to think about this rule, you can't do this and that unless you do this. And if every single person writing every product feature has to think about, oh, you can't do this unless you do this, or you've got to do this and make sure to do this thing, that's bad, because everyone's going to keep having to make that same rule over and over again. So when you're thinking about design patterns, you should think about ways to make it so most people don't have to think about it. And only a few people have to think about it. So another thing is, design patterns should make common things really fast. If something you do all the time is filled with boilerplate and filled with ceremony, that's really frustrating. You want common things to be really easy, and maybe like really weird, obscure things to be more complicated. So the thing that reminds me most about this is like a dependency injection framework we'll call small knife. So small knife makes everything hard or everything a little bit more complicated all the time. Like you constantly have to think about it. But we want common stuff to be easy. And so a phrase that I like to think about this is by the creator of Ruby. And he says, implicit is better than explicit if you and the computer agree. I don't know about you, but I never agree with computer. But even if you do, here's what the real quote is. Implicit is better than explicit if you, your entire team, and computer agree. And so the bigger your team gets, the more that doing clever stuff and building things based on convention and stuff like that is gonna kind of troll you, right? And the more that explicitness and being really straightforward will benefit you. So I think that straightforwardness and explicitness are really useful goal in a design pattern. So one last thing, putting similar code together is good. So like patterns like when you use decorators to kind of like join stuff together in all these pieces, and then you can't actually see how they're connected, and you kind of like mark it in 1,000 places, and then somehow they get built, like a certain small knife framework, is not great. We want to be able to see in one place how all these things are related. To understand how the pieces fit together. So of course, this advice is from Marie Kondo. Put all your similar items together. So, to that note, now we'll finally get to Flutter. Now that I've rambled on philosophy for like 15 minutes. So this is a library called Getlt, and Getlt is based on a Xamarin library I wrote called Splat, and it's really simple service location. So we had manual dependency injection talk earlier by Stuart, and this is going to be really similar. So this is how you do it in Flutter. So this kind of acknowledges that like service location, like your dependency graph, the thing that instantiates your components is really global variable, like at the end of the day. So we're not going to kind of try to obscure or hide that fact. We're just going to say it's a global variable. And so we're going to create, in our top level app class, we're going to create this class, this static called locator. And in our constructor, we'll call this static method called setup registration. And so how many people have read Dart code? There's going to be a few like Dartisms, and I want to explain them so you're not confused. So the most important one is you see like the get it with parentheses around it. That's a constructor. In Dart, you can leave the word new, the keyword new, off. You just don't need it. So when you want to create a class, you just call the name of the class parentheses. So that's important. And it's just a static method that returns itself called setup registration. And we'll see what that does later. And so, unrelated, but we'll just see this in another slide. We have this application mode up here called debug production test. As you imagine, you have debug mode production test. Drink some water for a second. So this points out some like cool Flutter tricks. So this first line shows how to check whether you're in test mode, whether you're in a test runner. It's a little bit hacky, but whatever. The next line is even more hacky, but it's like kind of brilliant. the way to detect whether you're in debug mode, like in a developer build versus a production build, is you set an assert, and asserts get strict in production. So we use these two booleans to build this enumeration. And then we just call this locator dot. Oh, here's another part of Dart syntax. How many people are familiar with the builder pattern? Almost everybody, right? Because you use it in Android constantly. When you use in Dart, this is built into the language. It's called a cascade operator. And you see locator dot dot. Dot dot means we're going to call this method, and then we're going to keep operating on the original variable. So locator dot dot register singleton. Dot dot is related to locator still. Dot dot is related to locator. So we're going to keep calling, and there's like register singleton, register factory, but it's really simple. It's really, at the end of the day, service locators are just a dictionary. Like they're just a map of like thing you want to thing you will create. And so that's really useful. And so we can write this all in one place. We can say like we're going to set up all our production things. If not, we're going to set up in debug mode, and we'll see some interesting things about that later. But we can just write it in one place, and that's really concise, and it's really understandable. So that's cool. And so the way that we use this is that Dart has this feature called kind of like inspired by the JavaScript style of having optional parameters. So that second line is defining two optional parameters for this method. And so here we're saying route observer equals the route observer passed in, which is usually null, unless we're in a test runner. Or question mark lets you say like this or that. I think in Kotlin it's called like the Elvis operator, right? I'm seeing nods, so that sounds good. Yeah, so that's like the Elvis operator. So question, I read this as or app locator. So we're saying like if the passed in test version is null, we're gonna call it to the locator. And it's just a regular static variable. There's nothing magic about it. So in our test, we can do really simple things like we can, one thing that I recommend when you do this pattern is to write a test that just runs the setup just to see if like your setup, this is really useful because it kind of instantiates the app and like checks to see if startup works basically. So that's just a really simple test that I just throw into every app. But the cool thing is that because this pattern is so dumb, there's things you can build on top of it that make it really straightforward to write unit tests that inject objects, right? So we're going to set up registration, and then we're going to set this Boolean called allow reassignment. Normally, you're not allowed to reassign things in Getlt once you set them up. But if you call allow reassignment, you're allowed to. So you can set it up, you're like, I want this to be all production except for this one class that I want to replace. And then we have this method called with locator that like, sets the global locator, runs a block, and then sets it back. It's really dumb. But it makes writing tests really easy. And so that's important, right? Like if we're using service location with or like dependency injection or service location, the whole goal is to be able to write tests and replace things in a unit test runner. If what you're using doesn't let you do that really, really easily, then like, you're not getting any value out of it. You might as well just be like, creating things directly. So Getlt is super fast. Getlt doesn't have any startup time because it's just a map, right? It's super, super fast. So in Xamarin, this is a bigger problem. People try to use like dependency injection built for servers, and then they'll allocate like 20 MB of memory on startup and take 5 seconds, and they're like, yeah, that's fine. But dependency lookup is really fast. And I was like, you can't spend 5 seconds on load In a mobile app, that's crazy. But so just a map is really fast. Getlt is super dumb, which is great. Dumb libraries are awesome because dumb libraries can be put together with other dumb libraries. It's really easy to compose things that are simple. There's this metaphor of like, what is the size of the Lego piece of this library, right? Like big Lego pieces are like Meteor, or like these other kind of frameworks that take over your app and like require you to do everything. Small Lego pieces don't do much, but they're really easy to fit in all kinds of different places, which is really cool and useful. Getlt is a small Lego piece. It's really easy to, on top of that, build something smarter that makes more sense for your application. And like I mentioned, the whole idea of service location dependency injection is to make it easy to replace, to write tests. And so Getlt makes things really easy to replace in tests. And that's great. Cool. So here's another feature of Dart that's really cool called implicit interfaces. So in Dart, every class is an interface, no matter what, every class. And the definition of that interface is the public members of that class. The consequence of this is that when you use third-party libraries, you don't have to write like dumb wrappers around every class as often, right? If you're feeling really paranoid, you can write the wrapper anyway. So for example, there's a class in Sirene called Login Manager, and it directly uses the Firebase user info class, which normally would be not great because like in Android, I wouldn't be able to create that class. I'd have like a private constructor. I'd only be able to like create a real version of it. In Dart, you can't create a class that's not, you can't create a dummy version of. So I can directly use these classes from Firebase. And then when I want to unit test them, I just implement the class. So this is useful in a bunch of places. So I use this also in to mock Firebase Analytics. So Firebase Analytics doesn't have any like interface or any kind of like mockable thing, but it doesn't matter. I just created a debug Firebase Analytics that just prints things, right? So every time when I'm running in debug mode, instead of it sending in junk analytics, it's actually just printing it so I can read what it says. That's super useful. So all kinds of things that you normally couldn't mock or would be annoying to mock are really easy in Dart, which is cool. So another pro tip I have for building Flutter apps is when in doubt, ask your React friends. So Flutter's UI kind of paradigm is similar to React. And so it means that a lot of the same problems happen in both. Things like maintaining like scroll position or like focus. So when you get stuck in Flutter, a great thing to ask yourself is like, well, how would I do this in React? Like what is the React community built to solve this problem? And odds are that these same solutions will apply in Flutter too. So that's really cool. So here's a great example. So there's this library called Flutter Hooks. So React recently released this feature called Hooks, which kind of drastically changes how you write applications. And so this is a code without using hooks. You don't have to read any of this, it's too small. The idea is that it's like super long. It's got a lot of boilerplate in it if you look into the details. A lot of stuff that isn't focused on the actual goal of this component. So here's the hooks version. It's super short and super clean. Sirene doesn't use hooks yet, but I think that it's like a really promising kind of new way to write Flutter components. Another thing that's really cool about Dart is the Dart linter is really great. It's great because it discovers a lot of its linters are really tied to actual performance and reliability and other problems that would actually cause you problems in your application. It's really high quality lints for the most part. You know, a lot of linters kind of really focus on like style things and like no white space at the end of the line. That doesn't make your program better. Dart linter, a lot of the lints are really directly derived from effective Dart, which is kind of like the Google guide on how to write Dart code. So for example, this code, shared pref set bool, returns a feature. It returns like an asynchronous result. But you don't actually care about the result because you're just setting a shared preference. You don't need to wait on it or like worry about what happens to it. But you can't see that in the code. Flutter has this feature called unawaited. So you can actually mark in the code saying like, I'm explicitly not awaiting this. I'm not waiting on this or interested in the result. That catches mistakes, right? Catches times when you actually did mean to write await and you did need to wait for this before something else happens. So that's super cool. So here's another example of a Dart linter that actually makes your program better. So Dart has this feature called const constructors, where you say like, I'm creating this class and I'm not modifying any objects and it's immutable. So prefer const constructors actually makes your app faster because Dart does this really interesting thing. It walks through all of your code and says, if this class is constant, I can create it at build time and then save it as like a chunk of memory. And then when the app's loaded, I'll just deserialize that from memory. And so it does this all implicitly. So that's really cool because it means that like all these classes that we normally have to instantiate, walk through a function, do all this stuff, it just like deserializes in one chunk, which is way faster. So here's the example. So in React, like Flutter, what you create in like a render is not, a widget isn't an actual like living control, kind of like it's not, in Android, like a text field is this object that lives for a long time and like has state and does stuff. When you write UI in Flutter, you're kind of describing what you want it to do, and then it will create the objects on its own. So this is really similar to, what's the library in Android? They just released it, it's like Compose. You're not creating the object, you're creating a tree of what you want to have. And then later somebody comes along and says like, okay, well we got this, we need this, okay, I'll create this object. Got this, we got this. This is called reconciliation in React. So anyway, because widgets are immutable, we can reuse them. So we see edge, it's an edge insets all is really, it's a widget, but it's really a constant, it doesn't change. It just says like make it this much, add this much padding, right? We only need one edge insets all with a size of 8 in our entire application. And so we can just reuse that same object over and over and over again. And so when we set that linter, it will remind us in all the places where we can write const to do it. And it'll make our app run a little bit faster, especially if you're in like a recycling cell, like a recycling view, where like object creation time is actually kind of is a big deal. All right, I'm running a little low on time, so I'll move really fast. Flexbox is amazing. So I added this slide like this morning because I realized that I didn't, how many people have used Flexbox in Android or other platforms? This is great because the rest of you are gonna like, your lives are gonna, this is the one thing that will like, you'll get value out of this talk more than anything else if you don't know Flexbox. Like Flexbox is incredible. And there's a version of Flexbox for Android as well. So you can write it in native Android. So Flexbox is a layout type. And so the idea of Flexbox is that it's like a stack, but all the items in the stack can either be as small as possible or as big as possible. And so you can say certain cells are like, I want this cell to be as big as possible. I want this cell to be as small as possible. And so once you realize this structure and like how you'll see it everywhere. It's everywhere. You can use it to build all kinds of user interfaces. So here's like the Google search bar, right? I like was searching for user interfaces and I was like looking at this. I was like, this is a perfect example. And I didn't even search yet. So this is a Flexbox that is horizontal with 4 items. The first item is as big as possible, the text box. And then there's 3 other items that are as small as possible, the buttons. This pattern happens in user interfaces constantly. So let's look at Instagram. The top level cell of like one picture and all its stuff. The top level cell is Well, you can even see the structure also is a Flexbox. Flexboxes are everywhere. So let's look at this just one cell. So we've got username and the picture and the place, and that's as small as possible. We've got the picture, which is as big as possible. We've got the button bar, yada yada, small, small, small. I made a typo there, but the top bar where it has the logo, that's a horizontal Flexbox where the Instagram logo is as big as possible, centered, and then the direct message button is as small as possible. Flexboxes are everywhere. So Flexbox is built into Flutter, and here's how you'd write maybe the top level of one of the Instagram pictures, right? So we say first the direction is vertical, and so Flexboxes, you say either vertical or kind of like start to finish, as opposed to like left to right. So when you go to right to left languages like Hebrew or Arabic, it'll flip it. So we say this is the axis is vertical, and we're just going to say the children is the username card. So if you don't specify in Flutter, if you want it as big as possible, it's going to assume that you want it as small as possible. Username card, as small as possible. We wrap Instagram image in this component called expanded. That's our way to say to the Flexbox, we want this to be as big as possible. The next one is the buttons, and we're going to wrap that in a different Flexbox going start to finish. So left to right in English locale. And we're going to say the buttons are, we want all three buttons to be as small as possible. So we're going to say like, comment, share. And then we have the other controls, which are also as small as possible. So Flexbox, really cool, really useful. Use it all the time. Cool. So the last tip I have, I wrote a blog post about this, so Flutter normally, when you install it as like an SDK, right? You install it globally on your computer. So I kind of didn't really like that because it kind of makes Flutter a little bit tied to your machine state. And so like, well, that's not great. And it's especially not great in a team because like, who knows what version of Flutter they have. And if you have like 10 people working on an app and they all have different versions of Flutter, you're gonna have a weird time. So here's a way to check Flutter into your app as a submodule, as a Git submodule. Git's most easy to understand and straightforward features submodules. Yes, cool. Why? So like I said, this gives you a few benefits. The biggest one is that everyone's on the same version of Flutter. And your team, it also makes CI a little bit easier because it means that you don't have to install Flutter onto the CI machine. So a lot of Flutter builds, the first thing it does is try to like download the Flutter SDK and fake install it because it's like a very like usery installer. So instead you can just do git submodule update. And you're pinned to the specific version of Flutter that you're using, which is really useful, and I'll show you why later. So first thing you do is you run some commands to check out Flutter, and you just pin it to the version you want. You check out a tag. So this is really similar to any other, using a submodule. So what you need to do then is write a little script called Flutter W, kind of like Getlt W. How many people know why Getlt W exists? It's pretty obscure. The reason why Getlt W exists is because Getlt W stands for wrapper. And what it does is it says, oh, you want Getlt 5.1? I'll go download it for you and then install it for you like behind the scenes. And then as you change your Getlt versions, it manages that for you. So that's why Getlt W exists. So this is Flutter W, which is the wrapper on Flutter. So it's really simple. So the Mac and Linux, really all it does is add Flutter's binary to the path and then run it. And on Windows, it's even dumber. It just calls the batch script. When you do this in VS Code, if you're using VS Code, I don't know how to do this in Android Studio, which is not great, but I'm sure somebody will figure it out. But in VS Code, you gotta put this extra Dart settings into your settings JSON file. And usually you want to check that into the repo. So the first thing we do is we set the SDK path not to the machine one, but we're going to say it's in our repo, it's vendor/Flutter. Like that's where you should look for Flutter in our own repo. We're going to say, we're going to tell Dart, don't analyze anything in the Flutter directory. Don't go crazy and try to run through the entire Flutter code base every time you open the project, because Dart gets up to like 1 gig of memory usage and goes, everything gets really slow and bad. So we want to ignore the Flutter SDK itself from analyzing. It also shows like thousands of errors because of like your settings and Flutter's settings don't agree. The last thing is when you're editing Flutter itself, don't run Dart format on it, which we'll see why later. But if you edit Flutter itself, you don't want to run the formatter on it. And so here's why. We're going to see a little demo. I hope this works. I'm going to switch this back to mirroring because otherwise I'm going to go crazy. Cool. So we're running the app. So this is why vendoring Flutter is really powerful. So Flutter changes a lot, right? It's not a stable, not a super, it's really evolving quickly. And so, just like any other framework, as you build on it, you might find things you want to change or things that are missing or things you need. The great thing about this is that with Flutter, you can do it. So this is the Flutter, the app code. We're going to go into phrase list pane. So here's the code that implements the actual list, these tiles. So you can see over here. Now what's really cool in Dart and Flutter in general is that go to definition is insanely powerful. Now I just jumped into the Flutter source code, and I can just read it, and I can keep go to definition, go to definition, go to definition. That's super powerful. What's really great about the Flutter source code is that it's super well documented. And understanding Flutter, like one of the best ways to do it is to just keep reading the source code. The time when I really broke through and started being productive with Flutter is when I was stuck on an airplane without Wi-Fi. And so the only way I could figure out how to do things was to go to definition on the control I was using and then start poking around. So it has this really great documentation. It's really understandable. But here's the cool part. Let's see if I can find my... So I can just keep going like, oh, what's decoration position? Go to definition. What's, this and that. Go to definition. I can keep jumping through the whole framework. So let's go to my canned example. But here's what's really powerful about checking out Flutter as a submodule, is that I can edit the framework and hot reload. Save. Just like my regular app code. So this property, the blur style, is not exposed. And maybe I care about that. Maybe that's like a style I want, so I can play around with it. I can change Flutter itself. And then see what happens. So maybe I want inner. What else does can do? Inner. And so no other framework that I know of, you can like edit the source code of the framework itself and hot reload. You can't even do that on the web. Like, super cool. So I think that normal was pretty good. So we'll put it back, hot reload. And so hot reloading Flutter itself takes kind of longer than normal because it's actually sending like huge pieces of Flutter itself over the line. When you hot reload your app, it's much faster. But yeah. So, and the cool part about this is it's a submodule. So I could just go git commit, save that change, and then ship it with my application. So I don't need to wait on the Flutter team to like make some small change. If they don't like my PR, I just run with it on my own. So I can ship custom versions of Flutter trivially easily, which is really cool. Cool, so that was the demo. And that's all I got. Thank you so much for your time. This is me on GitHub and Twitter. Questions, comments, concerns, rants, tomatoes to throw. Yeah.
Modify the Flutter that exists that everyone's using. How do you support things? Like, you run into situations where people are having their custom implementation, like things like Drupal and things like that. And then you change something in your API, and then it breaks for a bunch of people because they're doing custom stuff. Does Flutter suffer from that?
Yeah, so you wouldn't, the question was like, what, if you can change the framework whenever you want, won't that break people? And so the answer is, you would typically only do this for an app. You wouldn't try to do this for a library because requiring, if you're like, oh yeah, use my library, also you need a custom version of Flutter. That's not great. And so what you would hopefully do is take that change you made and submit it as a PR to the official Flutter repo. And if it's like kind of like something that they want, makes sense for everybody, they'll probably try to take it or at least incorporate that feature. So I've done that several times. And so, but if not in your own app, you'd only use it for yourself, right? And so the way you'd maintain that is that you would have a fork of Flutter, like the official Flutter repo, and then you, just like any other fork, you would keep like merging from upstream and like maintaining your version on top. Git makes it really easy to keep your patches on top of some other branch. So you'd have like some patch that fixes your bug, and then you'd keep like, you'd like update it like, I want 1.80 plus my fix. I want 1.90 plus my fix. And that's really not really easy, but like straightforward to do, and Git makes it really easy to do. Yeah?
Does Dart and or Flutter have a dependency manager so that you can pull in the source widgets, or would you recommend Git someone?
No, so normally the question is, does Dart and Flutter have a dependency manager? And the answer is yes. It has a great dependency manager called pub. And so pub is similar to NPM and these other dependency management frameworks. You write like a text file that describes what versions you want and it installs it for you. So for the vast majority of libraries, you use pub. Pub has a really cool feature that says you can, for this library with this name, just use this path. So you can use Git submodules, which is great for developing a library. Like you're working on a library that you're not finished with yet, and you're having to update it really rapidly. So instead of like publishing a bunch of like bogus like 01, 02, 03, you can use it as a submodule until it's stable, and then you can publish it. So that's really flexible and really cool feature of pub that I really like. Oh, I think we're at, thank you so much. Thanks for your time.